Math 230, Quest to College. I'm Joe Vasta, and this is the review for Exam 2. I'll call it Review 2. And this covers Chapter 3, Logic. So we're going to be doing the review exercises for Chapter 3. If you haven't worked on them, you might want to work on those problems before you watch this video. Let's take a look at a puzzle before we get started with the problems. What do these letters have in common? Okay, so what do those letters have in common? The other thing that I'm going to do at the end of the video is something where you'll need 2 strips of paper, some tape, and some scissors. And you're going to see something really neat, okay, that has to do with topology. So that is what we'll do at the very end. So what I'm going to start doing is going over problems from the Chapter 3 review. This is logic. So let's go ahead and get going on this. Decide whether each sentence is a statement. Put that down. Well, that is not a statement. That is a command. So this is not a statement. "12 divided by 2 does not equal 6. This one is a statement. Now they're not asking us for the truth value. We'll cover that later. So this is a false statement. 12 divided by 2 does equal 6. Did you do your homework? That is a question, not a statement. Remember, a statement has to be true or false, but not both. So this is not a statement. Okay, let's continue. So logic started off pretty simple, pretty basic. And now we're finding truth values of the statements. Okay, so these are all statements now, and we have to know our truth values. The sun rises in the north. Well, we know that that is false. And a reminder, do not morph your T's and F's and try to make it all the same thing, okay? Because I'm always going to pick the wrong one. So make sure you're clear when you put falses or trues. The next statement, true and false. Well, this is where you have to remember the truth values of and, or, not, if, then, or you have to know how to figure them out, look them up in your notes. True and false. And is the strict one. So he does not allow one of his friends to lie. So true and false equals false. We live on Earth, and Canada is the capital of California. So we live on Earth is true. Here's an and. Canada is the capital of California. That is false. So this gives me a true and false. Just like I had up there, true and false equals false. This statement is a false statement. A triangle has 4 sides, or, so here's the or, 4 is a prime number. Okay. A triangle has 4 sides. That is false. False or 4 is a prime number. Now remember, prime numbers only have 2 divisors. 4 has more than 2. It has 1 goes into it, 2 goes into it, 4 goes into it. So 4 is not a prime number. So 4 as a prime number is a false statement. So we have false or false, which gives me false. Let's look at this. If false, then true. Well, this is something that is a definition, and this right here happens to be a true statement. If false, then true is a true statement. If 12 is a prime number, so we already went over prime numbers have only 2 divisors, and 12 has more than 2 things that go into it. So this is if false, then, now we already know what the answer is going to be because we have an if false, but let's continue. Then 12 is evenly divisible by 5. So when you put 5 into 12, is that evenly divisible? And the answer is no. If false, then false, we have there. But if false, then false, that gives me true. So make sure you know how to analyze statements and find the truth value of different statements. Another skill that we learned is taking words to symbols, and then on the next page we'll go from symbols back to words. So let N be the statement, Hilbert looks nice today. M be the statement, Hilbert's mom picked out his clothes. And F be the statement, Hilbert forgot to comb his hair. Translate the following statements into symbols. So here it goes. Hilbert's mom picked out his clothes. Okay, so I'm going to start right there. Hilbert's mom picked out his clothes. That is statement M. But, so we talked about the but in this class, where the but is the contrasting and, so we're just going to put the symbol for and. And Hilbert does not look nice today. So, N was Hilbert looks nice today. Hilbert does not look nice today is going to be tilde N. And there's our answer. Problem number 11. Hilbert does not look nice today. We'll stop right there. So Hilbert does not look nice today is going to be tilde N for that first part. Or, so or is the cup, and is the cap, so or is the cup. Or Hilbert's mom did not pick out his clothes. So statement M is Hilbert's mom picked out his clothes, and then this one says Hilbert's mom did not pick out his clothes, so we're going to say tilde M. And that's that statement right here. Okay, the next question, we're going to symbols. If Hilbert did not forget to comb his hair, or Hilbert's mom picked out his clothes. So that's the hypothesis. Let's write that down. Hilbert did not forget to comb his hair. So that would be not F. Or cup. Hilbert's mom picked out his clothes. So that's statement M. That right there is the hypothesis. And in this class, we put parentheses around the hypothesis or the conclusion if they have like an or, and you know, and they're more complicated like this. So if this, then, there's the arrow for then, Hilbert looks nice today. So Hilbert looks nice today is statement N. So it looks like we have our answer right there. Let's go ahead and do this last one of this type. Hilbert does not look nice today. And then there's a comma. So that's actually a grouping, indication of grouping of something. So Hilbert does not look nice today. So that's tilde N. Or Hilbert's mom picked out his clothes. That's going to be M. And, so here's the cap. Hilbert forgot to comb his hair. That's an F. So there's the statement there, but this comma right here tells you what's going to get grouped together. And what will get grouped together are the two things after the comma, which is M and F. So I put parentheses around those. And now I have myself my answer right there. So that is how you do those problems. Let's go ahead and do the next one, problem number 14. We'll change the statements around. Let C be Grandma bought candy. P is the statement Grandma, oh, did I say bought? Brought candy. Grandma brought pie. And M is the statement Grandma gave me money. Translate the following symbols into words. So look at this. We start off, here's an if-then. If C, then not P. So if C, Grandma brought candy. Okay, so let's write that down. Grandma brought candy, comma. The if-then always has a comma right before the then. Then what? So if Grandma brought candy, then we're going to write not P. P is Grandma brought pie. We're going to say Grandma did not bring pie. Grandma did not bring. Do you think I can fit it on this paper? I think I can. Pie. There it is. So if Grandma brought candy, then Grandma did not bring pie. There's my answer. I'll box it. Woo. And then we'll go like that. There it is. And anytime, if you're actually watching this and you did not do your review, and anytime you can pause this and, like do the ones that you see here. Okay, this one right here. This is a P or not C. So let's start off with statement P, which is Grandma brought pie. Grandma brought pie. That's that statement, statement P. Then we have this right here, which is an or. Or, and then this is not C. So C is Grandma brought candy. This not C is going to be Grandma did not bring candy. Grandma did not bring candy. Well, you could actually say didn't if you like, but I went ahead and just spelled it all out here without a contraction. There's the answer to that. Let's finish these up here. Problem number 16. We have C and M or not P. So C is Grandma brought candy, and M is Grandma gave me money. So we could put those together and say Grandma brought candy and gave me money. Okay, so that is this first statement here. And because they have parentheses, I'm going to go ahead and put a comma. And then we're going to write the or. Okay, so this is or what? Not P, which is Grandma did not bring pie. So I'll write it below. Grandma did not bring pie. And so there's the answer. I wrote the symbols into words, being careful with my commas. Okay. Here's the last one. If this complicated statement here, then M. So let's start off by writing our hypothesis. If, so the hypothesis is not C and not P. So if Grandma did not bring candy and Grandma did not bring pie. I'm going to write that down. So if Grandma did not bring candy and Grandma did not bring pie, comma. Okay, so there we have if hypothesis. There's the hypothesis. That arrow is the then. Then what? Statement M. Then Grandma gave me money. And so there it is. Woo! Okay, so that's a lot of writing. This will probably be our most writing out sentences in this class. And after this, it will be back to numbers. Let's continue by doing problem number 18. Considering the following two statements, I forgot my sunglasses, it is raining. Write in words the conjunction of the two statements. Well, what is the conjunction? The conjunction is the fancy word for and. So this is what we're going to write. I forgot my sunglasses and it is raining. And it is raining. Okay, part B on this is the disjunction, and the disjunction is the or. We're writing in words the disjunction of the two statements, so it's going to basically almost be the same. It's going to be I forgot my sunglasses or it is raining. So I forgot my sunglasses or it is raining. And so there it is. That is problem number 18. Let's see if I can find problem number 19. So here it is. It goes onto that paper. Oops, I'm dropping papers here. Problem number 19. Write a disjunction that is equivalent to the given statement. Okay, so a disjunction is an or that is equivalent to the given statement, which is an if-then. So this is where we have to look up one of our laws of logic. And our law of logic says this. You've got an if P, then Q is logically equivalent to not P or Q, the alternative form of the conditional. Okay, because look, you've got a conditional and you want to write an equivalent statement that's an or. So this is what you're going to do. You're going to take a look at these statements. Here's the if and then, sorry, the then and the if. I'm going to rip that out because that's the arrow. The then is the arrow. I'm going to replace the then with an or. Okay, and then I have the first part and the second part. Which one gets negated? It is the first part. So the first part says he doesn't stretch. The negation of that is he stretches. Or he does stretch. I'm going to say he stretches. He stretches. Or, and then this stays the same. He will not be flexible. You could put won't if you want, but I'll just keep it like this. He will not be flexible. And that is how you write a disjunction that is equivalent to a conditional. You use this rule here. Write a conditional that is equivalent to this or statement, this disjunction. So now you're kind of going the other way around. And you're actually just doing the same thing. You're going from down here to up there. So let's see if we can do this. Here is the or, and you want to get rid of it. So look, here's the or. You want to replace it with a then. Okay, so I'm going to put the then right there. There's a comma, and then we want to put if. So this statement is Fluffy doesn't wear a collar or he doesn't bark. So now I've got the if then, I've ripped out the or, I'm traveling this way now. What part stays the same? Well, the conclusion does. And the part that gets negated is the first part, the hypothesis. Oh, well, it's going to be the hypothesis, but it's this first part that gets negated. So Fluffy doesn't wear a collar. We're going to say if Fluffy wears a collar. Whoops, okay. Fluffy wears a collar. So that part gets negated, and the second part stays the same. If Fluffy wears a collar, then he doesn't bark. And there it is. Now if I wanted to go back to the or, it would be like this top problem here, where they're asking me to write this if then as an or. So make sure you know how to do these problems when you take the exam. Let's go ahead and do problem number 21. Problem number 21 asks us to write the negation of all boys like math. Okay? Or in fact, we are writing the negation of the next 4 statements. I think that the next 8 statements we're going to be writing the negation of. All boys like math. So this is the one where we want to remember, if you see an all in your statement, then the negation is going to be some ... not. And then if you see some not in your statement, you're going to rip those words out and put all. And then the other one is if you see a no in your statement, you're going to rip that out and put a some. So look at this. I'm going to rip out the all and the all boys like math. And I'm going to replace that all with a some. And then somewhere down the line, I'm going to put a not. So some boys do not like math. And that is the negation of a statement that has an all. Look, let's go ahead, and so we replaced it with the some and the not. Let's do the next problem. Some people don't watch TV. So you have a some, and then down the line you have a not. So you have a some and a not. Some people don't watch TV, so I'm going to rip out those orange things, the some and the not, and replace that with an all. All people do watch TV, but you could just say all people watch TV. And there it is. The some and not got replaced with the all. Some cats are black. So I see the word some. Do I see a not later on in that sentence? No, I don't. So now I know that I'm going to replace that some with a no. No cats are black is the negation of some cats are black. And so there it is. Here's the no. The last one on this page is nobody can fix this car. So we have a no here, and it gets replaced with a some. So I'm going to say somebody can fix this car. That's good to say. You could also say someone can fix this car. So however you want to say it, someone or somebody can fix this car. And so the no got replaced with the some. And we have something that looks like that for our answer. So these are all the negations. I should have been writing them in red, so the next page I will write my negations in red. Okay? Not that that's required for the exam, but I should have been doing that because I can see some problems coming up that we don't want people to be confused with. Okay, so problem number, I think there's 37 problems in this review, so we still have a way to go. Write the negation of each statement. So this statement is an or, and we're using De Morgan's laws. I'm not going to write them down. And you've got three different things you've got to negate. So the negation of 7 times 0 equals 0, the negation of that is 7 times 0 does not equal 0. I'm having a hard time talking. Negation of or is and. Negation of 8 times 0 does not equal 0 is 8 times 0 equals 0. And so there's our answer. So we use some De Morgan's laws. Okay, the next one. I don't cook and you don't eat. Well, this is a statement that has an and in it, so we're going to do De Morgan's laws again. So I'm going to underline the three things that I'm going to take the negation of, and I do the negation of each of these. So the negation of I don't cook is I cook. Negation of and is or. Negation of you don't eat is you eat, or you do eat. I'm just going to say you eat. And so there's the answer for the negation of I don't cook and you don't eat. And you don't eat, yeah, I cook, or you eat. Okay, now this one's probably the toughest one for people to do, is doing the negation of the if-then. And I'm going to do it like I did it in lecture, even if it drives some people crazy, I don't care. I'm going to go ahead and rewrite this if-then statement. I'm going to rewrite it using an or, and we were doing that earlier where I rip out the if-then and replace the then with an or. So I'm not writing the negation of the statement yet, I'm just writing an equivalent statement. Okay, so now which one gets negated, the first part or the second part? The part that gets negated is always the first part. So the kids can't factor. Okay, so we can write that as the kids can factor. Or, and then the second part we just leave alone. They will not get their allowances. They will not get their allowances. So our original statement is, if the kids can't factor, then they will not get their allowances. We rewrote it to an equivalent or, the kids can factor or they will not get their allowances. What they asked me to do was write the negation of the statements. So now I see an or here, so we have three different things here, and I'm using De Morgan's laws. I'm going to write the negation of each of those three things. The kids can factor, so now I'm back to the kids can't factor. The kids can't factor. Negation of or is and. Negation of they will not get their allowances, they will get their allowances. There's wiggle room in this. You could have put, and they get their allowances. That would be acceptable in this class. So there we have it. Almost didn't give myself enough room here. Okay, but we'll have room to do this. Write the negation of this if-then statement. So once again, I'm going to change this to an or. This is just the way that I do this. The first part gets negated. So the negation of not A is A, and the negation of B stays what it is. The second part stays the same. Okay, so all I did was rewrite an equivalent statement, and now I'm going to negate each of these three parts. Negation A, and then the negation of an or is an and negation of not B is just B. And so there we have it. And on this one we went ahead and ripped out the if-then and put in the or, just like we did right there. Okay, so make sure you know how to work out problems like this for the exam. Let's go ahead and do a few more problems here. Problem number 29 and 30 are kind of the same. Find the truth value when P is true and Q is false and R is true. Okay, so the first one does not have an R in it, but that's all right. Let's go ahead and write out what we have here. I'm going to replace the P with true. So I have negation in parentheses, negation true, and Q is false, false. So this is where I have to know my order of operations, which we do parentheses, and then we do negation, and then from left to right we do ands, ors. That's how we're doing it in this class. So the next thing I want to do is negation. I want to do this one right here, negation true. Negation true, because I'm doing inside the parentheses, and inside the parentheses negation is stronger than and. So this is going to be negation. Negation true is false and false. Okay, so that's what I have right here. I'm still doing inside the parentheses. I have to determine what false and false equals. And what is false and false? False and false happens to be false. I'll circle that like that. And then I have not false, that equals true, and I'm done with this expression here. So I found the truth value of this. Now I'm going to go ahead and find the truth value for problem number 30. Q or not R, and not P, then Q. So I'm going to replace the P's, Q's, and R's with their values. So Q is false. R is true, so I have not true. P is true. We have then, and Q is false. Okay, so that's what we have. I'm going to work on both parentheses independently. So we have a not true, which I can turn into a false. And we have another not true right here, which I can turn into a false. So I'll do that. So this becomes false or false. And then over here we have false, then false. Okay. False or false becomes false. And I'm actually should write a little more here. This became this one. This one became this one. I am running out of colors here. Then we have if false, then false. That becomes true. So now we're left with false and false and true equals a false. And we're done with the problem. So these are the kinds of problems where they give you an expression, a statement, and you're trying to find the truth value, and you have to know your ands, ors, nots, if-thens. Problem number 31. Problem number 31 is constructing a truth table. So on the exam, I think I will put some lines just to make it easier for you. And we're going to see if we can get this done. I'm going to put a line across here. I'm going to give you more lines than you need on the exam, so there's always one student who tries to fill in all the rows. Please do not be that one student. They try to fill in everything. They're like, I better use all the space that he gave me. Not on this one here. Okay, so watch this. I have how many different letters? It looks like I have 3 letters, but I have 2 different letters, a P and a Q. So here's P, here's Q. I always start off with the scenario where they're both true. And then I'm going to alternate Q's by ones. So true, false, false. Okay, there's 4 rows in this truth table that has 2 letters. And so that alternates by 1, this alternates by 2's. True, true, false, false. So let's go ahead and build this structure here. Using order of operations, I'm going to go ahead and build up the conclusion inside the parentheses. So what do I need now? I need a not P. After I do the not P, I'm going to write the whole thing here, not P or Q. I can even put parentheses around there. And then the next thing I need is, well, the whole statement. I'm ready to actually write the whole statement after I get that part done. So this is Q, then, and then we have not P or Q. So let's see if we can build this truth table. I'm going to go get my bugs. They were on the other side of the room here. And the first thing that I'm going to do is going to compute the not P column. So P says true, true, false, false. I'm going to write false, false, true, true. Now I'm going to say not P or Q. So I'm going to have that right there. And or is commutative, so it doesn't matter if I say true or false or true. I'm just going to say it like I see it here. So false or true is true. False or false is false. True or true is true. And true or false is true. Okay, so we have that. Now what I'm going to do is I'm going to say if Q, then this, the column I just created. If Q, then not P or Q. Where I've got to remember that this one goes first and this one goes second. And it doesn't always work out that way, but it is on this one. So I've got to remember my truth values for if true then true. If true then true is true. If false then false is true. If true then true is true. And if false then true is true. So my final column, I don't know what I was circling, what color I was circling that in the lecture, but there's the final column. We've constructed a truth table and we are done with this one. Let's go ahead and do the next one. Construct a truth table for this statement. So this statement has 3 different letters. I see a P, a Q, an R. I see if-thens and an and. I do not see an or a tilde, a not, but that's all right. You should know how to do all sorts of problems like this. That line there. And we're going to go ahead and write in alphabetical order P, Q, R. And I always start off with true, true, true. There's 3 letters, so there's going to be 8 rows. The R I'm going to alternate by ones. True, false, true, false, true, false, true, false. The T, oh wait, the Q column I'm going to alternate by 2s. So there's 2 trues and 2 falses, and 2 trues and 2 falses. The P column I'm going to alternate by 4s. So we have 4 trues and 4 falses. So this gives me all 8 situations that I need. So let's go ahead and build this. I need a if Q then R. So if Q then R. So the hypothesis, well, it's not the hypothesis. What am I doing? There's an and here. So the first part is built. I want to build this part as well. If P, then Q. Okay, so that's that part. And now I can put it all together. So we'll just put this whole statement right here. And let's see what we do with this. So if Q then R. So this one's first, if Q, and then R is second. So if true then true, true. If true then false, false. If false then true is true. If false then false is true. If true then true is true. If true then false is false. If false then true, true. If false then false, true. So that's my next column. We have that complete. Now let's go ahead and do if P then Q. So I guess I have to cross this out where it says first and second because I don't want to get confused. If P, so that's going to be the first one. Then Q, that's going to be the second one. So let's go through this if then again. If true then true is true. If true then true is, we just answered that, true. If true then false, if true then false. Those ones are both falses. If false then true, if false then true. Those are trues. If false then false, if false then false. Those are also trues. So, whew, we got through that column. Now let's go ahead and both of these columns together. We'll put the bugs right under them. And is a little stricter than the or is. True and true is true. False and true. That's false. Once I see a false with the and, then I'm just going to put false. Like true and false is false. True and false is false. True and true is true. False and true is false. True and true, that's all true. So my final column looks like this. How many falses do you see in the final column? 4. So there may be a little follow-up question on the test that asks, how many falses are in the final column? And you'll just answer 4. But I'll also want to see the work. And let's just remind you that you could have put this column here over here, and you could have put this column over here. So you could have swapped these columns if that's how you wanted to do this problem. On this problem, you could build this one up first and then build that one. Okay, let's continue to do more review problems. Number 33. Write the converse, inverse, and contrapositive of each statement. Now on the exam, these might be switched around. So let's see if we can do this. Converse. So what the converse does with the hypothesis and the conclusion. So here's the hypothesis, he's not there. Here's the conclusion, I call later. The converse swaps them. So if he's not there, then I call later. The converse is going to say if, and then we swap them. If I call later, comma, then, and then we go ahead and put this one. He's not there. Okay, inverse. The inverse of that statement is not a swap, but it's a negate in front of each of those simple statements. So we keep the if here, so we have if, and then we just negate this. He's not there. Well, this one's going to say if he's there. And then we're going to negate I call later. Then I don't call later, or I do not call later. There we are. And then the last one is the contrapositive. The contrapositive is a swap and a negate. So you're going to start off by saying if, and you go over here. If I do not call later, you could say don't. Then, and then I go ahead and negate that. Then he's there. And this right here is the answer. We wrote the converse, the inverse, the contrapositive. Of course, now they're asking us to do it on this one. This will be a lot less writing. So let me go ahead and write converse, inverse, and contrapositive. converse is a swap. So remember these guys right here, there's the hypothesis, here's the conclusion. So we're going to swap them. So it's going to say if not N, then M. So there's the converse. The inverse is we're just going to negate them. We're not going to swap them. We're going to say if not M, then, and then we negate that N. So if not M, then N. The contrapositive is a swap and a negate. So I'm going to go ahead, this one's going to go first, but it's going to also be negated. This is going to be if N, then not M. And so that is how you do these problems. Let me go ahead and box this. And we only have a few more problems to do. 35, 36, 37. So let's go ahead and do problem number 35. Are the statements logically equivalent? Use a truth table to show your work. So what we want to do is we want to put both of those statements on the same truth table to see if they are logically equivalent. Now, how many different letters do I see? I see 2 different letters. So I'm going to write column P and column Q. And we start off with the same thing we always start off with, true, true. This one alternates by 1. And column P alternates by 2. Okay, I'm going to build up this first statement. So I'm going to need, you know what, I'm looking at both of these and I see this statement has a not P and this one has a not Q. So I mean, this is where you do have some wiggle room on the intermediate columns. You can put them in different order. So I'm actually going to put a not P for a column because I see it right there and a not Q right there. So now I could actually write this whole column P and not Q because I have the not Q. So P and not Q. Okay, so that's this one we have, and it's right here. Okay, I still have to go a little more on this. I need to go not P or Q, the parentheses, not P or Q, and then this whole enchilada, which is that whole thing, so the negation of what I just wrote. And so we're going to take a look at these 2 columns here and see if they are identical. Let's go ahead and do the negation of P, which is false, false, true, true. We'll do the negation of Q, which is false, true, false, true. Hopefully I said false, false, true, true. So this for not P, not Q is false, true, false, true. I don't know what happened to that F there. And then I'm going to AND together P with not Q. True and false? False. AND is strict. True and true? True. False and false? False. False and true? False. I'll circle this in its own color. Let's circle it in blue. And we're going to see if the other column will end up just like that. So now I'm going to go not P or Q. Not P or Q. False or true is true. Or is not as strict. False or false? False. True or true? True. True or false? True. Now I'm going to negate the column that I just did. The negation of true, false, true, true is false, true, false, false, and look what you have. You have exactly the same values in this column as you have in that column there. So it says, are the statements logically equivalent? The answer is yes. go ahead and look at our last page of problems, and we're going to come back to those puzzles. Write a different conditional statement that's equivalent to the given statement. If you are asleep, then you are not in class. So here's an if-then statement, and they want us to write a different if-then statement that's the same. Basically, what they're asking you to do, since you already have an if-then statement, is write the one that's equivalent. And which one is equivalent to the if-then? It is the contrapositive. So that's basically all they're asking you to write, but they don't want to say write the contrapositive. We already gave you a problem like that. They want you to know that the contrapositive is equivalent to that. So the contrapositive takes these two statements. It's the most complicated one. It swaps them and negates them. So if we go over here, you are not in class. So we're going to say if you are in class, comma, then, okay, so we've done the swap and negate on that one, and we're going to do swap and negate on this one. You are asleep, so the negate of that is you are not asleep. And that's the contrapositive, which means the same as the original statement. Okay, the last problem of the review is number 37. If you are cool, then you like math. That's great. Okay, suppose the above statement is true. Okay, so we're going to say if you are cool, we'll write that as C. Then you like math. So we'll just say if C, then M. So suppose this is true, and Elvin likes math. Okay, so this is Elvin. He likes math. Can we conclude that Elvin is cool? So here's a statement, and what is this statement right here? The first statement is true. What is this statement? This is the converse. We cannot assume the converse. So can we conclude that Elvin is cool? Absolutely not. Not from this logic right here. And so that completes the Chapter 3 logic review. And now let us go ahead and finish up our puzzles here. Puzzle. So why does B not belong in that list? And A as well. C belongs, but then D doesn't. So these are the misfits down here. And maybe you figure this one out. I'm just going to tell you the answer. These are all the letters in the alphabet where the lowercase letters are written like the uppercase letters. So that answers that puzzle. Lowercase and uppercase the same. Okay, something else that we're going to look at involves 2 strips of paper, scissors, and tape. So what you want to do is you want to tape that together and have a loop, and tape this one together and have a loop. So you have 2 loops. And then instead of going like that, you turn that and tape it together so it's like that. So I've already done the taping together for you. So we have something that looks like this. So what I want to have you think about is, what do you think you're going to get if I cut down the middle of the first loop and then of the second loop? And so that's what we're going to do. I'll try to stay in range of the camera. I don't even know how good this is going to come out. So I'm cutting down the first loop, and I'm almost done. So what it looks like I got is something that looks like handcuffs. Paper handcuffs. Okay, and now I'm going to cut on the second one. And it might be hard to see this all in the camera, but look what I end up getting. I end up getting a perfect square from 2 circles. So you might want to try that because it's pretty neat if you didn't think you were going to get that. Well, that's all. Study hard for the exam and have a good day.